All right, let's do it. This is Unit 3, Lesson 2. Hey, do you see what I see? Ready, set, let's go. All right, let's start with number 1. We're going to do word associate. Well, we're going to do association, right? Pencil is to writing as violin is to playing. Fishing is to lakes because you fish in a lake and you play soccer on a field. Equal slopes is to parallel, right? Because lines that have the same slope are parallel. As negative reciprocals are to perpendicular lines. All right, hexagon is to triangle as decagon is to. Well, a hexagon has 6 sides. A triangle has 3 sides, so it's half. A decagon has 10, so what has 5? Pentagon. Subtraction is to addition. They're inverse operations as division is to multiplication. Congruent is to shapes as equal is to numbers, right? Or measurements. Boom. All right, that wasn't bad. 1 through 6 done just like that. Here's the directions for number 7. So let's take a look at that. Decide if the following statements provide a true logical conclusion or if the statement is false. If false, provide a counter example. Okay, here's number 7. An acute triangle only needs to have one acute angle. Okay, that's false. That is so false. That's false. And here's a counter example. A right triangle, right? That means there's a 90-degree angle, which is not an acute angle, right? Has 2 acute angles, but is not an acute triangle. Boom, done deal. All right, there it is. That's a counterexample. If a rectangle is cut in half, then there will be 2 triangles. That's false. Come on, here it is right here. All right, now, if you cut it in half here or here, there would be 2 triangles. But what if I cut it in half there? Are those triangles? No. Or what if I cut it in half there? Would those be triangles? No. So that's a counterexample. All right? If you have supplementary angles, they would create a straight line. What? That's not true. That's false, too. Supplementary angles do add up to 180. Supplementary angles add up to 180 degrees, comma, but do not have to be a linear pair. But do not need to be a linear pair. So, for example, that angle and that angle could be supplementary, but they're not a linear pair, right? This and this. They could add up to 180. All right, but they're not a linear pair because they're not connected by that side. All right, if you have complementary angles, they will add up to 90. That's true. That is true. Complementary angles do add up to 90. By definition. Angles that add to 90 degrees are complementary. Boom. Let's go. Let's go. Okay, we don't do 11. We just don't. So we're going to move on. Oh, look at number 12. All right. List the steps. Okay. Well, the first thing I would do is construct AC. So I would start with this middle line segment right there. I think then I would construct, so listen, I'm going to do this, boom, right? And then I think I would do circle G, right? So create, so I'm going to create circle, and that's G because G would be the center of my circle, so that's circle G. Then I would probably do EF. No, I think I would then create circle A and C. Create circle A and circle C. That would be this circle and this circle. Woo. Then notice where they have the intersections, right? The intersection there and the intersection there. Then I would create EF through the intersection of those. Then I would construct, so that would be this. And the last thing I would do is construct the sides of the quadrilateral. Construct sides of quadrilateral. And that would be it. That would get it done. Let's see, what do I know about A, B, C, D? Well, I know that all the sides are congruent. Okay. So I'm thinking that ABCD is a square. Because AC is perpendicular to EF. So that means it creates a 90-degree angle here, 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 and here. Right? So that means all these triangles are equilateral triangles. So this triangle is equilateral, this triangle is equilateral because these are radiuses, right? And this is an angle. So by side, angle, side, that triangle is congruent to, let's see, let me do this. This triangle, by side, angle, side, this triangle is congruent to this triangle, is congruent to this triangle, is congruent to this triangle. So if they're congruent, that means corresponding parts are congruent. So that side's congruent to that side, is congruent to that side, is congruent to that side. It also, because these are congruent sides, it means these angles must be congruent. And so since that's 90, those are both 45. So 45 and 45 make 90 degrees here, 90 degrees here, 90 degrees there, and 90 degrees there. So it definitely is a square. And I just kind of did the justification verbally. All right? That's it. That was a good problem. I like that. Let's go to 13. Given the measure of angle C, 90 degrees. Okay, I'm going to assume that's the 90 degrees. Find x. Pythagorean theorem. X squared plus 10 squared equals 26 squared. X squared equals 26 squared minus 10 squared. X equals the square root of 26 squared minus 10 squared. Because to undo the squared, you square root. Let's do it. Square root 26 squared minus 10 squared. 24. Let's go. Centimeters. Please use unit of measurement. All right, that wasn't bad. No, that wasn't bad. All right, they told me this is 90 degrees. Okay, so what do I know? Well, this is a straight line angle. So x plus 90 plus 2x equals 180. Right? Straight line angles. Doesn't matter how many angles you have. If you add up a bunch of angles and it makes a straight line, then that's a straight line angle and equals 180. So you add up all the angles, set it equal to 180, add your x's, subtract the 90, divide by the 3, so x is 30, 30. Let's go. Let's go. Because x represents that, I'm going to call it 30 degrees. All right? 15, given triangle BEC and CED and DAB are right triangles. Okay? I don't see any right triangles right there. Oh, there they are. Okay, so they told me that's a right triangle, that's a right triangle, and that's a right triangle. All right, the first thing I'm going to do is I'm going to find BD. Okay, so BD is the square root of 8 squared plus 15 squared, because I'm using Pythagorean's theorem. So second square root, 8 squared plus 15 squared. 17, that's beautiful. So BD equals 17. Now I'm going to find BE. BE is going to be the square root of 14 squared minus 6 squared. So second square root, 14 squared minus 6 squared. Oh, 12.65, let's call it. So that equals 12.65. Okay, now I can find ED. ED is 17 minus 12.65, right? Think about that. This is 17. This is 12.65. So if I take 17 minus 12.65, that'll get me ED, which is that. All right? That's going to give me 4.35. So that is that value. Meters. All right, now I'm going to use Pythagorean's theorem again. And this is my final answer, right? This is x. X equals the square root of 6 squared plus 4.35 squared. The square root of 6 squared mas equals 7.41. So x is approximately, that's approximate because I'm rounding the answer. And don't forget unit of measurement for full credit, please. Meters. Holy Toledo, Batgirl, what's going on here? Label points C, E, and D with the correct ordered pairs. Oh, okay. I was a little confused there. Got to be honest, I didn't know what I was dealing with. But it looks like I'm dealing with this. Okay, so I'm gonna get organized a little bit because I need my diagram and my words to be with me. I need them to be with me. All right, so here we go. So there's the words, and there's the diagram. I'm going to fold this so we can get it all in there. I don't want that on there. Okay. All right, now I'm organized. Okay, let's do this. I think I'm going to need some pate. Paper. Someone get some. Okay, label points C, E, and D with the correct ordered pairs. Okay, I'll do that. So I don't know if I want to mess up my diagram, so I'm going to do it over here if that's okay. So C is negative 4, 0. D is 4, 0. 0, 4, come on, fool. And then E is 3, 3. Negative 3, 3. Okay. That's A. That's part A. Part B, translate CED down 4 and right 6. Okay? So down 4. 6. And that is C prime. Down 4. 1, 2, 3, 4, 5, 6 over 6. That is E prime. Down 4 over 6. And that is D prime. I'm going to get an edge that's straight. Okay, hold on. Let me read the directions. Okay. Oh, and they want me to include the new ordered pairs too. All right, all right. Notice that's a translation. Translations do not change orientation, just location. Size stays the same, right? Every aspect of the triangle stays the same. Okay, now let's do our coordinates for C prime, D prime, and E prime. And all I really have to do is subtract 4 from there and add 6 to there. So for example, C prime is subtract 4 and add 6. So subtract 4 is down, down 4 is the y. And then add 6 to the right is plus 6 on the x. Right, so this is y minus 4, and this is x plus 6. Okay, sorry, I had to get my bearings on that. Okay, so C is add 6, subtract 4. D, add 6, subtract 4. Add 6, subtract 4. Okay, that worked. Okay, let's see what's next. Draw C, C, O. Okay, now we got to draw a bunch of little line segments from C to C prime, E to E prime. I'm going to use a straight edge so it's pretty. There, that. There, that. That's a prism. We created a triangular prism. Hopefully we get into those later. All right, there's that. That's cool. I like that. Okay, draw C. Okay, did that. I'm on part D. This is B. That was C. And now I'm on part D. Reflect CED across the y equals 0 line. The y equals 0 line is the x-axis. So D stays the same. E double prime. I'm going to go a different color here because I want you to be able to see it. All right, so I'm going to reflect over that. This is going to stay D because it's on the x-axis, and the x-axis is the y equals 0. So that's D double prime. This goes here. That's E double prime. And this goes here. And that's C double prime. And then let's connect it. Boom. Da boom. And da boom. All right, that's cool. Include the new ordered pairs. Okay, okay. This is part D. So C double prime, D double prime, E double prime. Well, D double prime did not change. Okay, so that's good. C double prime is now 2, 4. And E double prime is 3, 1. Okay, part E. Draw C. Draw C prime, C double prime. Let's do a different color now. Well, no, let's do it in the same color. And then when I do the next step, I'll do a different color. Okay, so there's that. There's that. And there's that. Okay, that's awesome. Okay, it's looking good, looking good. I'm going to get another color. I'm going to get the blue. Where's the blue? There's the blue. All right, this is now part. What is the relationship between C, C prime, E, and E prime to the Y equals 0 line? They are equal distance. Okay, so part E is, they are equal distance. From the Y equals 0 line. Okay, so they are equal distance, right? That means that the distance from there to there is the same as the distance from there to there. They're equal distance away. The distance from there to there is the same as the distance from there to there. So those are also equal distance away. Okay, this is great. Rotate, my goodness. Rotate CED about the ordered pair -2, 0. Okay, let's do it. Okay, so -2, 0 is right there. There's C, there's E, and there's D. So I'm going to do that. And what I want to do is I want to rotate this until that arrow's pointing up. And right there. That is beautiful. Okay? So there's C, there's E, and there's D. C, E, and D. But it's C triple prime, E triple prime, D triple prime. All right, let's connect them. Woo! This is getting cumbersome in here. Okay, that wasn't bad though. That wasn't bad. Tall. Not tall. Okay, there's that. Include the new, oh my goodness. All right, let's do the new ordered pairs. This is F. This is the last one. C double prime. Hey, that's 0, 0. That's the origin. D double prime. That's -4, -4. E double prime. That's -1, -3. Okay, I didn't answer this. What is the slope of the line segments? All right, that's this, rise over run. So down 2 over 3. So the slope in part C is down 2 over 3. I'm going to go right here and do that. Okay. And then E, include the new ordered pairs. I think we're good. Yep, we're good. 16 is where we end. Woo! Let's go. Another one bites the dust. Okay, kiddos, stay strong. Be good. Woo! See you later. Bye.